Okay, so this is the second part of the review over polars. We're going to actually graph these 9 problems. Okay, so these came from the front page of the review that we just did from the other video. And here are the equations that you were going to graph. So from the first video, we decided this was, of course, a cardioid. Right? This is a cardioid. It is a limacon with a dimple at the origin. Okay, so we have 2 things to figure out. What is the outer radius? How far away from our origin is that?
6.
And we always do that by adding these 2 things together. 3 plus 3 is 6. So because it's a cosine, we're going to go along the 0-degree pole, which is the positive x-axis. So from our origin, we're going to count out 1, 2, 3, 4, 5, 6. We're going to put a dot there representing our outer radius. 3 plus 3 is 6. Not 3 plus 6. 3 plus 3 is 6. There's the outer. And then, of course, 3 minus 3 is 0, which is why the dimple is at the origin. Okay. Now the other thing we have to identify is the other pole's intercepts, and that's always the number in front of the plus or the minus sign. So that's going to be 3. So ours is going to cross at 1, 2, 3 units in the y direction, positive, and 1, 2, 3 units in the negative y direction. Okay, so here are these points. This is 6, 0 degrees. This point is 3, 90 degrees. This one is 3 and 270. And then, of course, we have 0, 0. So you want to make it look as roundish as you possibly can, with the dimple exactly at the origin. So there's your first cardioid. Looks like that. Okay, number 6, sine of 2 theta. We said this was a rose with 4 petals. So we have to decide some things. Where is the first petal? The first petal is at 90 divided by 2. For sine, it's always at 90 divided by the number in front of theta. Okay, and this is only for sine. We don't do this for a cosine graph. We only do it for a sine. 90 divided by 2 is 45 degrees. So 1, 2, 3, 4, 5, 6. This is going to be where our first petal is for our sine graph. Oh, that's not 4, that's 6. 1, 2, I counted 6, but then I wrote 4. This has a radius of 6. 1, 2, 3, 4, 5, 6, right? Exactly 45 degrees. This is our 45-degree line. Every one of these is 15 degrees, 15, 30, 45, 60, 75, 90. And then we have to decide what is their distance in between the petals. So this is how we do distance in between the petals. 360 divided by how many petals there are. 360 divided by the number of petals. Every petal is 90 degrees apart. Okay? So for sine, the first petal we define by doing 90 divided by the b, 90 over b, the number in front of theta. And then to figure out how far apart they are, we do 360 divided by how many petals. So 90 degrees is going to come over to here. There's our second petal. 90 degrees again down here in the third quadrant. And then 90 degrees in the fourth quadrant. Here are all of your petals. So those are the points. Now we start at the origin because the sine of 0 is 0. And we make a petal going out and back, and then a petal going out and back. Remember, I'm not grading you on the beautifulness of your petals or the precision of your petals, but rather on your coordinate points on the circle. Okay, 5 sine of 5 theta. Remember we said this was also a rose with 5 petals. So we have an odd number of petals because it's an odd number in front of theta. So the first one, 90 divided by 5, is 18 degrees. Our first petal is going to be at 18 degrees because this is a sine graph. So 18 is a little bit more than 15. 1, 2, 3, 4, 5, comma 18. Maybe that's going to be right in here. So there's our first petal for our sine graph. And now if we do 360 divided by 5, we find that all the petals are going to be 72 degrees apart. Okay, 72 degrees apart. So 18 plus 72 is 90. So we're at 5 comma 90. 90 plus 72 is 162. So let's see over here probably somewhere. 5, 162. 162 plus 72 is 234, which, let's see, where's 234? This is 225, and this is 240. So right in there somewhere, 234. And then our last one, 5 comma, add 72 to that is 306. And if this is 270, that means this is 300, and that's 315. So somewhere in here is 306. So those are your 5 petals. We start at the origin because the sign of 0 is 0, and we make our petals that go out and come back. Ooh, that one was not very symmetrical, but that's okay. I'm not grading you on your precision of your petals, but rather on the placement of your points. So there we have a 5-petaled star with a radius of 5. All right, let's see what else do we have. 1 minus 6. We decided this was an inner loop limacon because the B value is bigger than the A value. Okay, and it's negative, so that means it has a 180 degree pole symmetry. In other words, it's going to be opening, or the majority of your graph will be to the left of the origin, or pi pole symmetry according to ours. Okay, so the outer loop is 6 plus 1, which is 7. 1, 2, 3, 4, 5, 6, 7. Here is your outer loop. Your inner loop is 6 minus 1, which is 5. 1, 2, 3, 4, 5. So we have an outer loop of 7 and an inner loop of 5. Remember, the negative doesn't matter for your numbers. All the negative means is that it opens to the left. Okay, this is the negative. It doesn't mean that it's negative 6 plus 1. And then, where is it going to cross your other? It's going to cross your non-symmetry pole at 1. So we have a 1 above and a 1 below. Right, and of course it goes through the origin. So these are going to be some pretty looping loops. Looping loops. Okay, so let's see how we do. We make a loop that goes to the 5, back to the origin a little bit below so that it can get out and then come back through 1. And then a big loop around and then back through that 1. And then we're going to end up back at the origin. Right, so not a very looping looking inner loop, but good enough for us today.
Good morning.
Excellent. Let's continue. So here we have a 5 cosine of 4 theta. This is a rose with 8 petals. Whew. And our first petal is at 5 comma 0. For cosine, your first petal is on the pole. So in other words, the positive x-axis. 1, 2, 3, 4, 5. Here's your first point, 5 comma 0. Because the cosine at 0 is 1. So 5 times 1 is 5. Okay, that's why cosine starts on the x-axis, because the cosine at 0 is 1. And now we have 8 petals, so 360 over 8. Every petal is going to be 45 degrees apart. So we have another one here and another one there. Here a petal, there a petal, everywhere a petal, petal. old math teacher had a flower farm full of really pretty rose petals. And then you make an 8-rosed flower, 8-petaled rose, 8-rosed petal, 8 of them. Beautiful. Okay, our next one, r equals 6. That means that we have a circle with a radius of 6. So 1, 2, 3, 4, 5, 6. Here's your 6 radius, and you just trace all the way around the origin as best you can. I know tracing is hard, as you can tell. Tracing is hard. So there's your circle with a radius of 6. Nothing else to do. Let's see what else. We have 2 plus 5 sine. So once again, the b value is bigger, so this is an inner loop. And it's in the sine direction, which is the 90 degree, or the pi over 2, or the positive y-axis pole. So our loops will be going up. The outer 5 plus 2 is 7. 1, 2, 3, 4, 5, 6, 7. There's our outer loop. 7 comma 90, right? Because that's what the positive y-axis is, the 90 degree pole. And then 5 minus 2 is 3. 1, 2, 3. That's in here. There is 3. Okay. Now it's going to cross your x-axis, or the 0 pole, 2 units from the origin. So 2 to the right and 2 to the left. And then, of course, we have the origin as another point. Okay, so these are the dots that you need to identify. So let's make our inner loop. There we go, looping around. Go below your x-axis and then come back up and around. Oh, that should be fatter. Wider. Let's just make it a little wider. Oh, well. Oh, well. Back through that point, and there you go. Okay, 18, negative 6 sine of 3 theta. So this is a petal, rose with 3 petals. Okay, so we have 90 divided by 3. Our first petal is at 30 degrees. Okay, but notice it's negative 6. So when we go up 30 degrees, our first point is not here in the first quadrant, but rather in the third quadrant. So we're going to come to negative 6 comma 30, which is over here. Negative 1, 2, 3, 4, 5, 6. So here is your first point, basically at 6 comma 210. Okay, because it's a negative. Because it's negative, we don't start in the first quadrant. You go away from 30 degrees. Now all of our other ones, 360 divided by 3 are 120. 120 apart. So 210 plus 120 is 330, which is over here. There's 330. And then 210 minus 120 is 90. So it's going to be right there. Okay, so this is going to be a 3-petal rose that's basically symmetric with the positive y-axis. Okay, so it will look something like that. Okay, beautiful, beautiful. And then our last one, 5 sine theta. This is a circle. So this is a circle. Positive sign means that it's symmetric with the 90 degree pole. Okay, so a positive sign means it's going to be going up. So we put a dot at the origin. We go 1, 2, 3, 4, 5. That's the diameter. For this type of a circle, 5 is the diameter.
Huh? I'm gonna post on my store.
5 is the diameter. Okay, so it says it has a radius of 2.5. So there's the center right there. So do your best to make a circular circle that goes all the way around. So this one has a center at 2.5 comma 90. Okay, because when we have a circle that's not at the origin, this number is its diameter. It is not the radius. It's true for every other part, but it's not true for this type. Okay, so some things to remember when you're graphing. If you need some more help, go back and watch the other videos and look at your notes. I'm sure you'll do wonderfully well. Okay, goodbye.